Hey guys, welcome back to the channel. Today we are talking about something super important for anyone in data science or machine learning: statistics. We are going to cover two things. First of all, what statistics actually is, and the second one is how it's used in data science and ML. Alright, let's get into it. What is statistics? Think of statistics as the science of collecting, organizing, and analyzing data. In data analytics and ML, it's basically the foundation of everything. When you're training on ML model, you'll hear words like feature engineering, or feature selection. This is where statistics sneaks in and does all the heavy lifting. And what is our goal in machine learning? To make decisions based on data, right? And we need the decisions accurately, like as accurate as possible, right? Well, statistics is what helps us make those decisions accurately. Let me write the things for you, first of all, and then I'll describe it to you. Okay. Um, First comes collecting data. We gather different kinds of data. Could be numbers, it can be anything. And then remember, after collecting, we organize our data. So here, this would be organizing data. We perform feature engineering. This is the word I told you earlier: feature engineering and feature selection, if you can remember. cleaning, and formatting. So our data is ready for analytics. Sorry, analysis. And lastly, analyzing data. Like after collecting, then organizing, then we will analyze the data, right? Finding patterns. Like when we will analyze, we mostly want to find patterns. If we find patterns, if we track down any patterns, it's going to like make our work so much easier. Finding patterns, spotting trends, and getting insights, of course. That actually matters. Do you know why we find patterns? Like, as I told you earlier, that it makes our work so much easier because it helps us to build better ML or TL models. So, without all this process, like the process I gave you here, this fundamental tree, without this process, your ML model, yeah, not gonna perform well. Your model is not going to perform well. Okay, enough talking, but wait, what is data? We are talking about collecting data, organizing data, analyzing data, but what is data? Hmm? Simply put, data, um, yeah, data is just information, a piece of information that can be measured, okay? Measured. Like if I measure the height of everyone in my classroom, I might get 5 5'3" 5'5", 5'2", 6'5". This is a set of data. That's data. Now, if I want to actually do something useful with it, like finding the average height or see if there's a pattern, I'll need statistics. I need to imply statistics techniques in this set of data. Maybe I should go with the orange color. Yeah, it looks good. Now I would like to show you some email example. Say you have got a house price data set. Um, you might have area, the number of rooms, the location, and the price. City, area, rooms, price. Let's build an actual data set, shall we? Oh my god, my lines are so wobbly. It does not matter as long as you're understanding. Mm, okay, for city, let's put on the regular one, New York. And area, let's put 1,000 or okay. Anyways, and number of rooms, maybe 3 rooms, and the price. Uh, I don't know what is the price. Let's put X here, and then we can say Singapore, or let's put BD here. No, Dhaka. Dhaka area. Let's put 1,000. Number of room 5, and the price is Y. We're going to use this data set, this house price data set. Now, as a data scientist, you could analyze this data to create a report, or you can feed the data in a model. This is a model. This is your model, ML or DL model, and you're feeding this house price data set HPD. Let's call it HPD, house price data set. Here something is happening, and then you predict the house prices. Okay, it's a prediction. Prediction of house prices. Either way, statistics in this background making it all work. No matter you're making it, using it to build a report, or using it to make prediction of what could be the price. Okay, are you getting what I'm trying to say? Like, you have a data set, you have this city here. If you feed it in your ML model or DL model, first of all, it's going to pick, like, you have a bunch of informations, and in there your model is going to choose the important models, like city, of course it is an important piece of information, important data. And area, like the square feet of the house, how big is the house, how small is the house, and is there any like number of rooms. Based on this, in real life scenario, a house price gets fixed based on these scenarios, right? Like this same area, if this house is in some kind of village, the price would be, let's say, 1k, let's say. But the same house, if it gets shifted to a city, the same house, if it's located in a city, the price will of course rise. Like the 1k price, it will increase. This is the realistic way to think. And as a data scientist, if you want to analyze, to create report, statistics is a must in here. Okay, now I'll write a bunch of informations about where statistics shows up in machine learning. Basically applications of statistics and ML and data science. So what I'm going to do is I'm going to write them down, and then I'll make you understand. I'm done writing. So, application of statistics in MLDL data science. First of all, exploring and summarizing data. Here, you have to, before working with your data set, you have to get to know your data, what you're working with. You have to explore it, you have to summarize it. If you have a big amount of data, uh, common ML algorithms won't just work. Okay, like in your data set, if you have like missing values, you cannot use KNN or something like that, because the values, the data set, the data is going to be sparsed. Okay, and summarizing, I mean making something out of that data set, predicting something is going to fail you, is not going to give you the right amount of prediction. All right, so you got to first explore and then summarize the data, so that you can apply every type of ML classification models or algorithms to process your data. Okay, and then we have model building and validation. It's like making sure your model actually works. Okay, uh, this is this is actually a topic in AWS. uh, there is a service in AWS AI, if I'm not wrong, that is called AWS Studio. Oh God, what I'm writing. That is called AWS Studio. Uh, Basically, what you do here, you have the option to, what can I say? You have the option to compare models. Okay. And the best part about AWS is you can get your own data and input it into a model, and they'll adapt the model themselves. Or if you lack in data, you can fetch the data from their services as well. uh, it's actually amazing, guys. You should definitely study AWS. It's actually very beneficial. Anyways, let's get back to our application of statistics. In number 3, we have statistical analysis, studying a sample to say something about the whole population. Now, you just can go around and talk to every people in a city to know what is their height, right? What is the average height of that city? Is this logical? Is this realistic? No. Like, what type of clownery it would be, right? So what you do here, instead of talking to every single person in a country or in a city, you choose a sample size and you study the sample, and based on the sample you say something about the whole population. Now, the key factor here is all the people in a country are somewhat similar, right? I mean, they're pretty much same on average. It's not like in a village. Let's not talk about country or city, let's talk about a specific village. In a village, if the average height is 5 feet 5 inch, okay, so it says that the people are the grown up people, their height are somewhat between 5 to 6, right? Or there could be a 7. But is it possible that a group of people are having an height of 5 feet 5 inch, where another group of people are having a height over 6 feet 5 inch? It's not possible, right? So if you choose a sample, it's still going to not going to differ much than the others. So it's always wise, if you have a big population, if you have a big sparse data, or if you're collecting, you, instead of studying the whole population, you take out a small sample size, you study that, you study it thoroughly, and you make a report out of it, or you say something, or you make your own prediction, and it's going to imply on the whole population. It's not like the people that are not in your sample size are going to be different, right? Like, and different than your sample size, they are, if they're pretty much same. So it is a very good statistical analysis. Is Okay, it is okay. So next, we have hypothesis testing, checking if your assumptions hold up. Okay, and to do this, you have different type of hypothesis. Okay, I'm going to write some name here. Just check if you can relate with them or not. Null hypothesis. Guys, you just go and google it, okay, and or ask AI. It's going to give you a lot more example and experience rather than me. uh, alternative alternative hypothesis. P values. Yeah, basically there are more. Just as I say, just do put them in your AI, and just get whatever information you need out of them. And the last, optimizing efficiency, fine tuning. Okay, fine tuning, so everything runs smoothly. This is the final boss. You have to fine tune it. uh, I'm going to bring up my example from AWS. As I said, there are models, pre-built models, where you have to feed your data. Okay, you have instead of saying pre-built model, let's say you have a house. I'm going to draw it. Yeah, okay. You have a house, a nice little house. There's a window here, and this is the door. This is a empty model. I mean, empty house. Okay, it is a pre-built house. This is a pre-built house. Okay, and if you have furnitures, okay, you have furnitures, you have AC, you have sofa, bed, table, and so these are your data set. Okay, these furnitures, these are basically your data set. Okay, this is your data set, and this is your ML model, and this is an empty house. So what you do, you take your furnitures, you put your furnitures in your house, and then you place it accordingly, right? So this is called fine tuning. You have to fine tune it, okay? Otherwise your home will look like a mess. You won't put your bed into the kitchen, right? It's not going to happen. You won't put your AC into shower, right? It's bizarre. So after doing all these things here, like exploring your data, summarizing your data, model building and validating your data, then statistical analysis, and then hypothesis testing. You have to optimizing efficiency. Okay, you have to optimize, you have to fine tune, so that everything runs smoothly, so that you can live peacefully in your house. All right, so then you can move smoothly in your house. Okay, if you're feeling hot, you can turn on the AC if the AC is in your room, not in your kitchen. Okay, I hope I was able to make you understand. I don't know, but I hope I was able to make you understand. Okay, moving moving to the next. What's happening here? Okay, however, yes. Okay, two. Okay, now there are two main types of statics. Okay, descriptive statistics and inferential statistics. I like the yellow color. Descriptive, I sometimes forgot how to spell them. Descriptive statistics, and then we have inferential statistics. Summarizing and organizing data to make it understandable. That is the main key factor of descriptive statistics. Summarizing and organizing. Organizing to make it understandable. That makes me question if the CSV file falls under this category. CSV or TSV file. Anyways, key topics are measure of central tendency. Mm, it's basically mean, median, and mode. And then measure of dispersion. It is variance. Yeah, I really don't know what I'm writing at this point. Gosh, no. Standard deviation. Standard deviation. Then we have data distribution. It's basically histograms, box plots, and so on. As you can see, distribution. Box plots, pie charts. PDF, PMF, yeah. PMF, and so. And then we have five number summary. It's basically quartiles, Q1, Q2, Q3. These are known as quartiles. And then mean, max. Okay, five number summary. Q1, Q2, Q3, mean, max. So here goes our descriptive statistics, measure of central tendency. These are mean, median, mode values. Mean, median, mode process. Then for the measure of dispersion, variance, standard deviation, and variance and standard deviation. I think I forgot, but variance is denoted with mu and standard deviation is like the sigma square. I have to recheck. Okay, about so data distribution, it's histograms, box plots, pie charts, PDF, PMF, all the charts that will show you distribution of the data. And in 4 we have 5 number summary, that is Q1, Q2, Q3, quartiles known as the quartiles, and min max values, as simple as that. Now it's time to move on to this part, which is our inferential statistics. It is basically drawing conclusions about a population based on a sample. The key techniques to do this are hypothesis testing, then p-value, then confidence intervals, statistical test, there are many types of test, by the way. There are z test, t test, ANOVA, and so on. So yeah, I have told you this part. This is very short. Now time for a quick example. Descriptive versus inferential example. Imagine you have 20 students, okay? You have 20 students and 20 students in your statistics class. So for a descriptive question out of this could be, what is the average height of the class? And to find this, you have to use the mean. Okay, of course you have to use the mean, which falls under the central tendency. Look here. Central tendency. Yeah. Central tendency. Median. Mean. Central tendency. And if you want to ask an inferential question out of this, could be, are the heights in our class similar to the heights of college students in general? Here you have to use inferential statistics. Okay, so yeah, that's about it. Okay, moving to the next. Okay, for okay, now we will talk about population and sample data. There is going to be a lot of writing here. A lot of writings here. So I'm going to teach you verbally, and then I'll write the stuffs you need to know. Population is like the entire group you care about, the entire group you are studying. Okay, the example could be all students in your class. No, all students in your school. Okay, the parameters. Okay, and about the parameters, a numerical value summarizing the population. Mu for mean, and sigma square for variance. Okay, and sample is a small group from the population. Like here I'm making a small group, and this is our sample. It's like 50 students from your school, And for the statistics, a numerical value summarizing the sample, its sample mean and sample variance. And why use samples? Because in many cases, collecting data for the entire population is impossible, unrealistic, and impractical. That's where random sampling comes in to ensure results are unbiased. The example could be, for example, skill study. 50 students from the school. It will estimate average height for all students. Then market research. $500 consumers from a city to generalize purchasing history or purchasing patterns, behavior. City, or could be a mall, you know. Then um a good a good field is medical study. You take 200 patients and you test a drug's effectiveness. In these cases, I have shown you these cases, okay? In these cases, we use hypothesis testing. confidence intervals. And p-values to ensure our conclusions are reliable. So, I would like to tell you the characteristics in a broad way. So, about population, this is going to be fast. Okay. Population. It is a complete set. Okay. Hmm. It is a complete set. It contains all the observations, and the parameters are population mean, which is mu, and population variance, which is sigma square. And if you want to make a population in a school study, it will be all the students in a school, and you will determine the average height of the students. This is your population mean. And population in a market research, you will just take all the consumers in a city and you put them in a test. You analyze their behaviors and you bring something out of it, a result, a report. Okay. uh, so yeah. And in about medical study, it's all the patients with a specific disease to study the effectiveness of a drug. And if I talk about the characteristics of sample data, it just would be a subset of a complete set. This is just it just represents a proportion of the population. And the statistics is just a numerical value summarizing the sample data. It could be sample mean, sample variance, and the random sampling. These samples should be randomly picked up to avoid bias. And the examples are sample, like a sample in a school study, a group of students from your school. Sample in market research is 500 consumers from the city, behaviors, and then population. Sample in a medical study is 200 patients, test effectiveness to test effectiveness of a drug. So yeah, that's about it. I know I have just repeated the same thing. I just wanted to make it clear. I just felt like this was not this was like too uh, what do I say, too short. So I just wanted to make it like verbally. I just wanted to present you verbally the description. Okay, so yeah, that's about it. I think this concludes. And uh okay, I have taught you population and sample data. Okay, although there are like types of sampling techniques, but the video is getting too long, and I'll make another part of statistics. It will be statistics part 2, where I'll show you the types of sample techniques and the non-probability samplings, types of data, scales of measurement, uh, and then yeah, I'll it's just I'll there's still a lot of things to cover, but the video is getting too long, so I'm just concluding here. And before going, I just want to give you a final tip. A final tip that is parameter. I feel like I haven't touched on this way. Okay, final tip is parameter. It describes the population, and statistics, it describes the sample. Okay, and that's why statistics isn't just math, it's the secret weapon that powers accurate, reliable, and efficient machine learning models. So yeah, that's it. Thank you so much. We'll see you in the next video. Bye bye.